Hello, today we're going to be working on multiplying radicals. In order to multiply radicals, we also need to know how to add radicals. So we're going to start off with a quick recap on how you add different radicals. So the first thing you want to do is you want to look for radicals that are all alike, meaning that the radicand has to be the same number. If that is the case, then you are going to be able to add all of these different root 10s together. And in order to do that, you are going to add the numbers in front. So this is going to be a 4 root 10 plus a 1 root 10 minus a 7 root 10. So 4 plus 1 minus 7 would give us -2. That coefficient is going to go in front of the root 10, and then you're going to leave the root 10 all alone. For number 2, you need to make sure you know which ones are like and which ones are not like terms. So 6 root 3 can be combined with 1 root 3. If there's nothing there, there's technically a 1 there. That would give us 7 root 3. And then the 4 root 2, unfortunately, has nothing else to combine with it. So we're just going to leave it as 7 root 3 plus 4 root 2, and there's nothing else we can do because nothing else simplifies further. For number 3, these radicals are not simplified yet. However, we can simplify them first and then add or subtract them. So looking at number 3, we're going to go ahead and we're going to take and we're going to look for the highest perfect square in each of these. So 2 is the highest perfect square. It doesn't break down anymore. It's not even a perfect square. We just leave it alone. Root 8 is the same thing as root 4 times root 2. And we know the square root of 4. The square root of 4 is 2. So while we leave the first one alone, the next one is 3, and then the square root of 4 is 2, and then we're going to leave the root 2 that was not a perfect square inside the radical. And then our last one, we have the 2. The square root of 32 is the same thing as the square root of 16 times the square root of 2. And we know the square root of 16, that is 4. So we're going to bring the 4 out. We're going to take that square root of 16, but we're going to leave the square root of 2 behind because that did not have a perfect square. So you find all of your squares inside of there, and then whatever you bring out, you're going to actually multiply together with whatever coefficient was there. So this second term here becomes -6 root 2. The first term is 6 root 2. And your last one would be 8 root 2. After that, you look for your like terms, and all of these happen to be root 2's, so we can combine them together. So 6 root 2 minus 6 root 2, those two completely cancel out, and you are left with 8 root 2. So for adding radicals, find the like radicals and add them together. Sometimes you have to simplify first, though. So multiplying radicals is going to look a little bit different. So let's say you have these two radicals up here, a root b and c root d. A, b, c, and d can be any numbers. When you have one radical times another radical, you're going to take the numbers on the outsides and you're going to multiply them together. So whatever a and c are, you multiply them together. And then whatever numbers are on the inside, you also multiply those together. So we're going to do b times d. So that's the general rule for one times another. So let's look at an example and then we'll write out the steps. So this first one, I have a 5 on the outside and a 3 on the outside, and I can see that these are being multiplied together. So 5 times 3 gives us 15. Then the 6 and the 12, even though they're not alike, we can still multiply them. So we're going to do 6 times 12 to get 72. So our first step here is to multiply the coefficients. That's the outside numbers. And the radicands. That's the inside numbers. So coefficients is your outside numbers, and your radicands are your inside numbers, whatever's inside the radical. After you multiply them, if we're looking at 15 root 72, This is not simplified, so our next step here is going to be to simplify whatever we have left. So the 15 we're going to leave alone, but the square root of 72, we're going to break it down. 72, I know all of my perfect squares, if you think about them, 1, 4, 9, 16, and keep on going. 72 is 36 times 2. And I know the square root of 36 is 6. So I'm going to take the square root of 36 and put the 6 on the outside. And the 2 does not have a square root. That's nice. So we're going to leave the 2 alone. When we bring out the square root of 36, which is 6, the numbers on the outside, you're going to multiply it just like you did before. So that should give you a 90 and then a root 2. So multiply the outside parts, multiply the inside parts, and then simplify. So taking a look at number 5, we're going to do the same idea. We're going to multiply the outside parts. 4 times 2 is 8. We're going to multiply the inside parts here. 5 times 3 is 15. And then sometimes you look out here, 15 is 5 times 3. There's no perfect squares in there, so this is just it. For number 6, we're going to do the same thing. So think about multiplying the outside parts. We have the 4. We have nothing in front of the other one, so you can imagine a 1 there. 4 times 1 is 4. Then we're going to multiply the radicands, the 3 times the 27. 3 times 27 gives us 81 inside our radical. Now this one is one where the square root of 81, we know this already, the square root of 81 is 9. So this problem is really saying 4 times the square root of 81, which is 4 times 9. So this is one of the weird ones where you have no radical in your final answer because your square root was a perfect square. So instead we do 4 times 9 to get 36. So now sometimes we don't just have one term multiplied by another term, we have one term multiplied by more than one term here. We have a binomial. You can see the subtraction. So whatever this first term is, which is root 2 for this one, you're going to distribute this to each of your terms that are separated through addition or subtraction. So we are first going to do, I'm going to back up here, root 2 times 5 root 2. So you're going to multiply the outside parts, 1 times 5, and then you're going to multiply the inside parts, so 2 times 2. Then we're going to go ahead and distribute. We're going to do 1 root 2, and we're going to distribute it to the root 3. So we're going to multiply the outside parts. 1 times 1 stays a 1. And then the 2 times the 3, we're going to multiply those together to get 1 root 6. So your first step here is to distribute. The second step after you distribute is to simplify anything that can still be simplified. So looking at this, 5 root 4, the square root of 4 is a perfect square. So the square root of 4 is 2. The square root of 6 has no perfect squares in there, so we're going to leave that one alone. And then we just have a little bit of a cleanup here. So we took the square root of 4 and got 2. 5 times 2 gives us 10. And then we have minus the square root of 6, because that did not simplify any further. So we're going to see another one of these. The same idea is going to occur. So we are going to distribute. So we are doing 2 root 6 first times 3 root 3. So as you imagine, 2 root 6 times 3 root 3, if we were to multiply those, you're going to multiply the 2 times the 3, the outside parts. And then you're going to multiply the inside parts, the 6 times the 3, to give you 18. Then we're going to distribute the 2 root 6 to the 7 root 7. So we're going to do 2 times 7 to get 14, and then 6 times 7 to get 42. After you have distributed, you're going to simplify the same way you have been. So the square root of 18, the highest perfect square in there is 9. So the square root of 9 is 3. So we're going to bring the square root of 9 out as a 3, and we're going to leave the square root of 2 alone. So 6 times 3 would give us 18, and then we have the root 2. We still have this other one to simplify though, so if we look at the 14 root 42, we have to see if 42 simplifies at all. And 42 is 6 times 7. There are no perfect squares in there, so we're just going to leave it as 14 root 42. And we cannot combine them any further because they are not like terms. So we're going to move on to two binomials being multiplied together. So the steps are going to remain the same. It's going to be to distribute and then to simplify. The distribution process is going to be just a little bit longer now because we have to take the 6 and we have to multiply it first by 5 to get 30. And then we have to multiply the 6 by root 2. And those ones don't have anything to multiply. The 6 is on the outside and the root 2 is on the inside. So you just write it as 6 root 2. But then we also have to distribute the negative root 3 to the 5. So we're going to do negative 3 times 5 to get negative 15. But we're going to leave the root 2 alone because it doesn't multiply to anything. And then we're going to do the negative root 3 times the root 2. So negative 3 is your number in front, your coefficient, and then you're going to multiply 2 times 2 to get 4. Then we need to simplify. So I see over here that the square root of 4, I know this is 2. So this last part here is saying 3 times 2. So I have 30 plus 6 root 2 minus 15 root 2, and then a minus 6, because that 3 times 2 would give us 6. At which point we have one final thing, we can combine like terms. So 30 minus 6 is 24. 6 root 2 and 15 root 2 are alike. So when you have radicals that you are adding and they are alike, you add the numbers in front to get negative 9, but you leave the radical alone. So 24 minus 9 root 2. So we're going to try one more of those. We are going to take this 10 and we're going to distribute it to each term in the second parentheses. 10 times root 2 is 10 root 2. 10 times 3 root 5 is 30 root 5. We're going to take this negative root 5 and distribute it to the root 2 to get negative root 10. And negative root 5 times 3 root 5 is negative 3. And then we're multiplying the roots, so root 25. At which point, the only simplification that can happen is that this last one here, 3 root 25, that is a perfect square. I know that is 5. So 3 times 5 is really that last term. So I can write it as 10 root 2 plus 30 root 5 minus root 10 minus 15. There are no radicals that are the same, and there's nothing else that simplifies or breaks down, so we can't combine anything. This is just our final answer. Thank you very much for listening. I hope this helped.